Okay, so here we have a little piece on the Pythagoras Theorem, which I'm guessing we're all quite familiar with, but just a little recap here won't hurt us. So the Pythagoras Theorem, it comes from right-angle triangles. It is a result that only is relevant to right-angle triangles. And in a right-angle triangle, many moons ago, a chap by the name of Pythagoras, surprisingly, came up with a neat little result, and that is that in every single right-angle triangle there is this fantastic thing going on where you have the if we label our sides so that we know what we're talking about. C is called the hypotenuse, and that is the longest side of the triangle opposite the right angle, and the two shorter sides, A and B, doesn't matter which one's A and which one's B, but what results from this is a nice little formula that the square on the hypotenuse is equal to the sums of the squares on each of the smaller two sides. So C squared equals A squared plus B squared. Everyone's heard of that, everyone knows about it. It's just to make sure that we use it accurately, I suppose, is the important thing here. And so let's look to solve some problems involving using the Pythagoras result. And now if I draw some less neat triangles, you'll forgive me, hopefully, as we just look at some examples. So there's our right angle there, and I'm going to give us some sides to work with, 4 and 8, and in this case we are going to be trying to find the length of the hypotenuse, the longest side, x, on this triangle. So we use the Pythagoras result. It's a right angle triangle, so we're allowed to do that, and the Pythagoras theorem says that x squared will equal 4 squared plus 8 squared. So we work out what 4 squared and 8 squared are. Well, 4 squared is 16 and 8 squared is 64, so that's sum those together, I get 80. So x squared is equal to 80. I don't want x squared though, I want x, so x is equal to the square root of 80, which is an exact result. But if we were to get our calculators out, which I'm doing now, and work out what the square root of 80 is, then we could get a decimal result also, 8.94 to 2 decimal places. I reiterate that it is important to be able to come up with the exact result, which is left as a surd, as a square root, and a calculated result, which is an approximation, as long as we write in brackets what we've approximated to. Please remember to take notes on all these videos that I put up. So I'm expecting to see these notes in your books in class tomorrow. Alright, let's have a look at another example where perhaps we are trying to find not the hypotenuse but one of the shorter sides, and there's a little trick in here that catches some people out. So I'm going to say this is 13 centimeters here, and that this side is 9 centimeters. So what's this side going to be? Okay, let's have a look at this. The Pythagoras theorem states that c squared equals a squared plus b squared. C is always the hypotenuse, so we're going to be very careful here that we put into this slot the value here. Now in the first example, that slot there was the unknown, so we just had to work out the other side, add them together, the squares, and then take the square root. Here it's slightly different in that we know the longer side, so that goes in here. So we have 13 squared equaling 9 squared plus x squared. X is now one of the two shorter sides, so rather than x squared being here and knowing what this is, it's now over there. X squared is therefore equal to, I'm going to subtract this 9 squared from this side, so therefore it'll be on the other side 13 squared minus 9 squared. If we look at subtracting 9 squared, or 81, from both sides of the equation. So then we are left with x squared equaling 13 squared minus 9 squared. We can work out what that is. 13 squared is, I think we'll find is 169 9 squared is 81. So just checking my work there, subtracting 81, so we're left with x squared equaling to 88, and so therefore x is equal to the square root of 88, which is our exact answer. And if we're going to approximate it, then we'll find, using our calculator, that it's 9.38 centimetres to 2 decimal places, which looks about right. It should be smaller than 13, and so that's what we've got. So there's a couple of examples of using Pythagoras' theorem to find the one of the lengths in a right-angled triangle given the other two lengths. If we're going to find a shortcut in order to answer one of these questions, if we're trying to find one of the shorter sides, then we are simply saying that x squared in this case will equal the hypotenuse squared minus the other shorter side squared. If you want to go straight to that point, then I guess we are just heading straight into that section of the equation, and we're just cutting out this step here. As long as you understand what you're doing, I'm quite happy for you to jump to this step. Identify very early in the question, first up, are we finding the hypotenuse, or is it one of these shorter sides? If it's the hypotenuse, then it will be x squared equals 8 squared plus 4 squared in this case. If it's one of the shorter sides, it will be x squared equals 13 squared minus 9 squared, which is what we found in this case. So I'll leave it there, and we'll do some questions in class tomorrow. See you then.